All right, so we're talking about quadrants. We need to put our quadrants in, and we're talking about where 675 degrees is. So if I start by subtracting 360, so I've already gone around once, I'm going to get 315. So to go all the way around once, you get to 360, and then you keep going around until you get to 675, but that would just be like going around once, really, up to 315 degrees. Now if you go up to 315 degrees, so that bit's 315 degrees all the way around to there, then this little angle inside, let's make it a big fat angle here, that angle, it's not so fat, is 360 take away 315, which is 45 degrees. So just remember, whenever you're looking for the angle, you always, if I draw a line in that quadrant, it's that angle. If I draw a line in that quadrant, it's that angle. Draw a line in that quadrant, that angle. Draw a line in that quadrant, that angle that I'm really interested in. All right, so this is the 360 minus theta quadrant. This is the 180 plus theta quadrant. This is the 180 minus theta quadrant. This is the theta quadrant. Okay, so the quadrant in which it's located is called the fourth quadrant, because we have 1, 2, 3, 4. So it's the fourth quadrant. The coterminal angle, that is between 0 and 360. So instead of saying this, we could also say 315 degrees. Right? It would mean exactly, we'd get to the exact same spot. And the reference angle is the acute angle. So the acute angle is this 45 degrees. So we actually just looking for a little angle to use. So then if we wanted, for example, to find cos of 675, all stations to central, in the fourth quadrant, cos is positive, so it's going to be the same as cos 45. Whereas if we were finding sine of 675, we know it's negative in that quadrant, but it is the same as sine 45. It's the negative of sine 45. And if we were finding tan in that quadrant, it's also negative, but it's the same as tan 45, the magnitude. So the quadrant helps us with the direction.